Motor base assembly. So for this assignment, you're going to model all the components for the motor base assembly. As far as the hardware, the bolts and nuts, you can either download them or you can model them yourself, but I'm also going to email you the loose hardware, bolts and nuts. All right, so I want you to notice that this is in millimeters. So units are in millimeters. You can tell by the threads. So here we have threads called out. Anytime you see an M in front of a number, it's indicating metric units. In this case, 10 millimeters for the major diameter on the threads. Here's another example. You have a bolt that has a major diameter for the threads of 12 millimeters. All right, so let's take a look at the base plate first. So you're going to model the base plate first. This is probably the most complicated part you're going to model in this class. And this can be very confusing, so I decided to create a second handout. This is the original handout we've been using for years. So I decided to create a more simplified version of this handout and break it up into different pages. So once again, we're going to model the entire assembly. This is the top assembly, and it's going to be made up of smaller assemblies. This smaller assembly, this one, and this one. Let's go to the next page so you can see the smaller assemblies. So these are small assemblies inside of the top assembly. And later on, we are going to be creating a drawing of this assembly. And this is just a preview. Here's an exploded view so you can easily see all the components and bolts and nuts and a parts list. And again, this will be covered in the drafting lecture in a few weeks. Okay, so let's start by drawing a sketch of the base plate. Okay, so I want you to notice that this edge doesn't match this edge. They're not collinear. I want you to notice this dimension of 172 from this edge to this edge. But from this edge to this one here, it's 174. Okay, so we'll come back and take care of the 174, but for now we're going to draw a rectangle. That's 172 by 260. So the distance from here to here is 260. And notice how it doesn't line up with the edge of the tab. All right, so let's go to CATIA. Okay, we're going to go into a part design workbench. I'm going to sketch on the XY plane, horizontal plane. It's up to you which sketch you want to sketch on. Okay, so let's go to sketch. Okay, so next to profile, we have the rectangle command. I'm going to go to centered rectangle. And I'm going to pick my origin as the center. So to keep the rectangle centered about that origin. There it is. Let me check to see if I'm in millimeters. So if you're not sure which units you are currently in, let's go to Tools Options. Hit the plus sign on the General. Go to Parameters and Measure. Go to the Units tab. Go to Length. And make sure you have millimeters instead of inches. And OK. All right, so notice that these are orange, these icons. These automatically generate dimensional and relationship constraints depending on which command you use. Okay, so it didn't create symmetry, but it's similar to symmetry. You can see that this rectangle is staying symmetrical about the vertical and horizontal. It's similar to symmetry, but instead what it did, it created a equidistant relationship between this vertical and the vertical axis, and this vertical and the vertical axis. So the distance here and here will always be equal or equidistant. And then there's also a parallelism constraint between this line and so on. So it didn't use symmetry to generate the rectangle. It used equidistance, and it used parallelism to establish a relationship with respect to the origin. All right, so let's go ahead and throw in our dimensional constraints. So we know this is 260. And we know the depth is 172. Okay, and later we'll take care of the 174 issue. Okay, now we also have a inside rectangle, so let's use a center rectangle again. So you can see it stays symmetrical. Okay, so we need the dimensions for this inside rectangle. Let's click in space to deselect. Okay, so we have 24 millimeters and 26 millimeters. Okay, so let's go ahead and throw in those dimensions. Okay, dimensional constraint of 24. By the way, if you ever accidentally turn off the sketch tools toolbar, which is very common, it gets in the way and you will exit out and now realize that it's been turned off. So if you ever accidentally turn off some toolbars, like the sketch tools toolbar, just right click on any icon and turn it back on. Sketch tools toolbar, it'll bring it back. Stock it up here. All right, so we're still missing the 26 millimeter dimension. And okay, and it's symmetrical. All right, so let's go ahead and exit, but before we do, let's do a tool sketch analysis. Everything looks good. Okay, let's exit. Okay, so now we're going to do a pad. Okay, so if we go back to the drawing, the pad will be 12 millimeters. Now we're going to cut it in half. We're going to go 6 millimeters in each direction for a total of 12. Okay, so we're going to do a pad of 6 millimeters. Preview. There it is. But we're also going to mirror it so it goes 6 millimeters in the opposite direction of the sketch. There it is, preview, and that's a total of 12, and okay. All right, so now let's do a sketch for the tabs. Okay, so we have our tabs. So we'll just have to draw one, and then we'll do mirror to create the other three. Okay, so note the distance from the edge to the center of the arc or circle is 18 millimeters, and the radius is 14. Okay, so we'll come back if we need to check the dimensions again. All right, so we're going to do a sketch again, and I'm not going to do it on the surface. I'm going to do it on that same XY plane as the first sketch. All right, so I'm going to go ahead and instead of using profile or arcs and lines and circles, I'm going to use elongated hole to create that profile. So I'm going to go to elongated hole, one of my favorite commands. And as I mentioned earlier, it generated dimensional and relationship constraints because these are turned on. Again, the default is for these to be active. You can turn them off, but then it will not generate these constraints and it will not hold the shape of the elongated hole. So I'm always going to keep these on. All right, so we know our radius is 14. We know the distance from the edge to the center of the arc is 18. Okay, now we don't have an arc at the bottom here, but we do have a line with respect to this edge. So I'm going to draw a line from this tangent point to this one. There it is. And I don't need this arc, so I'm going to turn it into a construction element. So basically, when we do a pad, it will ignore that element. It's just a construction element. Now don't forget to turn it off, or else any new element you create, it'll turn it into a construction. Okay, so we're gonna hold on to the control key, pick the line and the edge, and place a coincidence constraint. There it is. Now if we take the tab, we can move it left to right. We cannot move it up or down. So that means we need a horizontal constraint. We'll come back and add that constraint after we mirror the profile over to the left. So let's select everything about that profile, and we're going to mirror it. So let's mirror about the vertical axis. There it is. And notice they will always be symmetrical about the vertical. And now we can add a constraint between the two. Let's go get that dimension. Okay, so that dimension, there it is, center to center is 180. And for the vertical center to the center is 160. Okay, so let's type in 180 and then we'll do the 160. Okay, so dimensional constraint from center to center is 180. Okay, so now we're going to mirror these two profiles. I select them. And let's go ahead and mirror them about the horizontal. There it is. Okay, now even though it's fully constrained, I still want to check that dimension from center to center, which should be 160. Put that dimensional constraint from center to center. There it is, and we get 160. Now it's over constrained. So we can either delete it, the 160, or double click and turn it into a reference element. It'll place it in parentheses and it's a reference only dimension. Okay, click in space to deselect. Okay, everything looks good. Let's do a tool sketch analysis. Everything is closed. Let's exit. Now, one thing about the tabs here, I want you to notice it's centered with respect to the neutral axis of the first pad. That's because we did our first two sketches on the same plane. Now, if we go to the drawing, you can see that the tabs are thicker than the frame. The frame is 12 millimeters. The pad is 16 millimeters. If you go back to the original drawing, you can see that the tabs are 16 millimeters in thickness and the rectangular frame is 12 millimeters. Okay, so we'll go with 16 for the second pad. Okay, so we're going to select our second sketch, do a pad. And this time we'll go up to 8. And don't forget to mirror it, so it'll go also 8 in the opposite direction for a total of 16. And there we have it, as you can see. Okay, now let's do the next set of pads. Okay, so now we're going to do this pad. And later we will address the issue of the 174 versus 172. Okay, so let's focus on the sketch for this tab. So we'll sketch one of them and then we'll do mirror. Okay, so all we have to do is sketch one tab. So let's go ahead and sketch this one. Notice from the edge here to the center is 22, radius of 14. I also want you to notice that this edge here doesn't line up with the edge of the rectangular frame. There is a 4 millimeter offset. So from the edge to the edge of the tabs is 4 millimeters. Okay, so let's go back to this view. Again, 4 millimeters from the edge of the rectangular frame to the edge of the tab. All right, so let's go ahead and draw this profile. Now this time we don't have a plane here, so we'll just use this planar surface. Again, it's preferred to draw on a plane. It's safer. Because if you were to draw on a solid and if the solid changes or if the solid is deleted, any sketch on that surface will no longer be able to exist. Okay, so let's go ahead and just draw on the solid planar surface. Okay, so let's zoom into this area. Okay, so once again, I'm going to use elongated hole like we did on the previous sketch. Just guesstimate the size for now. Okay, so we're going to use a radius of 14. Enter. And like on the previous sketch, we're going to draw a line from tangent to tangent point. We're going to now select the arc and turn it into a construction element. There it is, as you can see. Then click in space to deselect and turn standard back on, or else any new elements you create will come out as construction lines or dashed lines. All right, so let's go ahead and let me hit normal, make sure everything is parallel. All right, so now I'm going to pick this edge, hold on to the control key, this line, and add a coincidence constraint. And once again, the distance from the bottom of the surface to the center of the arc is 22. And we have a 4 millimeter offset from this edge of the rectangular base to the edge of the tab is 4 millimeters. Okay, now we're almost there. Now here we have an issue. Notice there's a gap here. We need to fix this. There shouldn't be a gap here. If we go back to our original drawing, it's hard to see here, but if we look at it on the opposite side, there's no gap here. It's a nice transition from this tab to this one. All right, so we need to fix that. If we go over to the updated drawing, notice there's no gap here. We currently have a gap on our sketch, so we need to address this. We're gonna take our profile and extend it inward and come back and close it off. Okay, so let's go ahead and alter our sketch. Okay, so what I'm gonna do is draw, using the profile command, I'm gonna draw a line from this line. And later on we'll use coincidence to line it up with this edge. Click and do a vertical and click. Okay, and hit escape to exit. Okay, so once again, we're trying to avoid this creating a solid that has a gap here. So we're gonna address it with these two lines. Okay, so let's take this edge, hold on to the control key and this edge, and let's make it coincident. There it is. So our profile is gonna go around, stop here, turn right, go down, and then we need to close this off. Okay, so we're going to have to use trim extend to intersect this line with this one. Okay, and remove or add any excess. There it is. Or to extend if need to. There it is. So there's our profile. And now we need to remove this portion. Okay, we can use trim extend again, but just to show you a different way, I'm going to use the eraser, the quick trim. Here's the quick trim eraser, and I'm going to remove this portion. Okay, now we have a profile, right, that's closed. Now this line, one thing we don't want is this line to be too far from this tab where it still creates a gap here. We want to close off this gap. So we're just going to extend it so it clashes into this pad, which is okay. It's okay if we create a pad that clashes with another pad, it'll just blend it in. So it doesn't matter how far in we go, as long as it stays inside this pad. So I'm going to put a dimension here, and we'll just round it off to a nice number. I'll just round it off to 10. It should work. There it is. And there's our profile. Let's do a tool sketch analysis. Notice it's closed. Okay, everything looks good. All right, so let's go ahead and exit. Again, once again, we extended this so it can blend into this pad. So we can have a nice transition with no gap. Okay, exit. Oh, one thing I did forget to do is I forgot to mirror it over. Let's go back to the sketch, double click on the sketch. I forgot to mirror it over to the right side. Let's select everything, do a mirror about the vertical. There it is, tool sketch analysis. Good, everything's closed. Yep. Exit, and we'll do our pad. Okay, we'll do our pad and then we'll mirror the pad over to the other side. Okay, so let's take a look at the drawing, see how much the pad is on this one. Here it is, 14. Okay, so 14 millimeter pad for this tab. So let's do a pad of this sketch of 14 millimeters. 14 and preview. Notice it's going in the wrong direction, so I got to hit reverse button. Preview, there it is. And okay. Notice there's no gap now. That's what we wanted. We wanted to get rid of that gap. That's for the reason we extended. So it did blend into this solid. Okay, so it did a Boolean operation and just blended the new solid into this one and same into the frame. It did blend it in. Okay, so now let's mirror these two tabs. So I'm going to select the pad, last pad we created, and we're going to use the mirror. Okay, so use mirror, and we're going to mirror it about the vertical. Oh, wrong one. This vertical. There it is. There's a preview. Hit preview to see the solid. Looks good and okay. All right, so everything looks good. Now let's address the 174 dimension. So going back. Okay, so remember we talked about the 174 versus the 172. So it's 172 from here to here, but 174 from this edge to this one. Okay, so let's check those dimensions. Now, if you want to leave it alone, I'm not going to take any points off. If you want to leave it the way it is, it's okay. I'm not going to take points off. I know this is a very complex part, so I'm being lenient on this one when it comes to grading. But if you want to fix it, let's take some measurements just to double check. Use your measuring tools. So this is 172 as it should be. But from here to here should be 174, and it's not. So if you wanted to do it correctly and fix this, what we're going to do is we're going to take this pad and extend it 1 millimeter outward. And because of the mirror command, it'll also extend it on this side. And it'll make up for the loss of the 2 millimeters. So it'll increase it by 1 and 1 for a total of 174. Okay, so let's go back to this pad, the last pad we created. And we're going to extend it 1 millimeter outward. Okay, so we're going to click on the More tab. There's a second limit, so now it's going to go in the opposite direction. And I'm going to increase it to 1 from 0 to 1. As you can see, it's giving us a preview. It's thickening outward. Preview, there it is. But now we have a thickness of 15, 14 plus 1. So we need to drop this to 13. So you can see we're going to remove 1 millimeter from this side to make up for the extension on this side. 13 plus 1 is 14, so that'll work. Okay, and it'll also update the other 3 tabs. It'll update them. So now when we take our measurement from this face to this one, now we get 174. Okay, it's been fixed and we're good. Okay. Oh, let me remove this. I don't need it. Delete it. All right, so we still have the holes and we have fillets, and we'll be done with this. Let's look at the original. Notice how there's fillets. Okay, so this is either an aluminum or a steel. Oh, it looks like it's steel. Okay, so this appears to be a steel base plate. So the base plate was casted in a mold. So it was liquid metal poured into a mold. And once it's dried and cooled down, it'll be taken out of the mold and then it'll be machined. Now these surfaces are rough surfaces, just like on this one also. These are rough surfaces. And the rough surface is due to the mold. So the mold, after being used, it will not give us a nice clean finish after multiple uses. So some areas need to be cleaned up, and once you remove it from the mold after it cools, you'll place it into a axis machine, a Fadal or Haas machine, and machine the surfaces here. So wherever you see a little V, you have to go in and clean up that surface. So this V is for this surface here, and we also have clean surfaces here. So the reason for machining these surfaces to a nice, smooth, planar surface is because there's going to be parts mating up to it. And in this case, we're going to bolt this base plate onto a work table and bolt it down. So the bolt needs a nice clean surface to mate up with. Same thing with this one. This clean surface will have to mate up with this surface under the head of the bolt, and so on. So we need to go in and add fillets. And again, these fillets are due to the mold. The mold has fillets, and there's a radius of 2. Here it is. So here we have this general note telling us to use a radius of 2 for all rounds and fillets unless otherwise specified. Now, one thing I chose to do is to make this optional. So if you see my note, I said, hey, this is optional if you want to add fillets. If you want to leave them out, I'll understand. Fillets are the biggest headache in modeling. So the rule is anytime you create fillets is you wait towards the very end to create your fillets. When it comes to a straight edge, fillets are no problem. It's when it has to turn. Anytime a fillet is going around a curve, let's use this one as an example. So anytime a fillet is going around a curve, sometimes it doesn't know which direction to go. And it can stop, or sometimes it'll give you an error message. So you always save fillets for the very end, especially where there's a lot of twists and turns, especially in aerospace. A lot of the machine parts are not rectangular. There's a lot of curvature to them. So sometimes the fillet will not know which direction to go, and it'll give you an error message, or it'll conflict with another existing fillet. Okay, so all rounds are 2. So this will be optional. So let's go ahead and do some fillets. And once again, if you want to leave them out, you may. Okay, I'm going to do the fillets for practice, or for those that want to see how to create them. Okay, so I'm going to create fillets, and I'm going to do it I'm going to use the fillet command a few times, so I don't have to do fillets all in one shot. If you try and do too many fillets in one shot, there might be error messages, and it's going to be hard to find where the error is at. So I'm going to do a few fillets at a time. So I'm going to do the fillets around this tab first. So I'm going to use fillet command and radius of 2. Notice that the default is tangency. Let me explain what that means. So if I was to pick this edge, it'll turn red. And notice this here turns like a red dashed line, letting me know, hey, even though you chose this edge, it continues with tangency. And it ends here, it'll terminate here. So even though I only selected this edge, it recognizes tangency and it keeps going till there is no more tangency. When it reaches the sharp corner, the tangency ends. Or I should say tangency continuity, something you'll learn in CAT 37, surfacing in CATIA. Okay, so now I'm going to keep going around, select this edge, select this edge. Notice it keeps going. See the dashes? It recognizes that even though I selected this edge, it continues on because it recognizes tangency, and then it stops once tangency ends. Okay, now let's do the same thing on the other side. I'm only going to do a few fillets. I'll do this one here too. And hit OK or hit preview. Okay, I'm going to hit OK. No error messages. All right. Okay, so let me add a few more fillets. I'm also going to add this inside fillet here. And I'm going to do this corner fillet here. And hit OK. So once again, I added the fillet here and this one here. And later on, we'll do a fillet along this path here, or this edge. Okay, so I'm going to go ahead and repeat it for all 4. So I'm going to just double click on edge 1, fillet, or edge fillet number 1, instance 1. Notice I've selected 9 elements. If I was to hit this little bag here, so think of this as a little bag of edges that I've chosen. So it's telling me these are all the edges I've chosen. You can remove them, you can replace them. You can just deselect if you want. If you want to remove a fillet, you can always click to deselect, or you can remove it from here. I'm going to close this sub window here. All right, so you're going to see this increase in numbers as I pick more edges. Okay, so let's go to the other side, and I'm going to pick the same edges as the first one. If you select an edge by mistake, let's say I chose a surface by mistake, lights all this up, you can always click on it to deselect to remove it. Okay. We have this one. this one, and it kept going, good. And let's do this one, and the inside, okay. Let's hit OK to see what we get. No error messages, good. I'll just reselect again. And again, the reason I'm doing a few at a time is because sometimes you'll get an error. And when you select so many, pre-selected so many edges, that it's difficult to go back and find the error. Okay, so let's select these edges here, all right. Again, this is optional. Okay, let's go around the tab here. And it continues on, okay. I'm just gonna go a little bit faster. Okay, and hit OK, make sure everything looks good, yes. Okay, let's go to the final corner here. May have forgotten, yep, I did forget the one on the other side. Select this edge. Okay. And again, just to emphasize, typically you wait to the very end to do fillets. We still have to do holes. Oh, notice how I mistakenly clicked this surface. Let me click it to deselect. There it is, and OK. All right, so that's one fillet operation. All right, so now I'm going to do a second edge fillet operation, and I'll do the rectangular area. Okay, so now I'm going to fillet the rectangular area. Okay, I think I got all the rectangular area. And hit OK. There it is. Oh, I did miss the inside area. Okay, so one thing I did miss on the first one is forgot this edge. So even though I picked this one, it didn't fillet this area. So what I'm going to do is go back to the first one. Oh, it happened in all of them. It only did this portion. It didn't continue on as I expected it to. Okay, so I'm going to go back to the first fillet, edge fillet, instance number 1. Well, my mistake, it did do this one. So I'm going to have to do this portion here. So what I'm going to do is go to the edge fillet number 2. Let's see what happens when we picked this edge. Hit OK. All right. So it was edge fillet number 2 that I forgot. I also forgot to pick this inside edge. Hit OK. Okay, that's better. And I need to click this one. So let's go back to edge fillet number 2. Okay, that looks cleaner. All right, looks a lot better. Now, one thing you can always do, you can always go back in time. So if I want to see what it looks like without the fillet, I can always right click, define. Right click define, and it'll place these as dormant, I guess you can say. It'll ignore these, and it'll only show you the history up to this point. So when right click define, it's like going back to the past. If you want to come back to the present, just right click on the part body and define. It'll bring you back to the present. Okay, so I'm gonna have to do this also for the others. So, okay, so let's go here. So edge fillet instance number 2. So I gotta go back and do these here, which I missed. So now I gotta go to all of them, all 4 corners. And okay, there it is. I think I got them all. Let me double check, make sure I didn't miss anything. Okay, now there may be a concern as to this can be manufactured as far as the mold to make this part when you pour the liquid in, liquid metal. But that's a whole different topic. It's not covered in this class. All right, so now let's go ahead and put fillets around the vertical tabs. Okay, so let's create a new fillet instance, edge fillet instance. So that'll be instance number 3. So let's do 1 tab and see what we get. So I'm going to select the top of this one and top of this one. Okay, hit OK and see what we get. Now it's just giving me a warning like, hey, double check that this is what you want. So this is a very common warning when you create fillets. It's basically telling us, hey, you know what? Check if this is what you want. One thing I did not want to fillet along this edge. If you go back to the original handout, notice there's no fillet on this edge. And the reason is because this is machined. So maybe it did have a fillet at first and it had excess material beyond 16 millimeters in thickness. And then the machine shop came in and smoothed this out, again, because most likely a bolt. And it's because it is a bolt that's going to bolt this onto some type of work table. Okay, so again, we don't want this edge with the fillet. Okay, so we need to fix that. So I'm going to double click here. Okay, notice we mentioned tangency before. Let's see what happens when I go to minimal. So I don't want it to continue its path along a tangency. So because tangency was the default, it kept filleting and it kept going around because it recognized that there was curvature or tangent continuity. All right, so I'm going to take this off, go to minimal. Notice it already removed it. So I'm going to hit OK, see what we get, and it stopped. Okay, good. So it stopped. Now we may not need to fillet this area. If we look at the PDF file, so it kind of fillets this area. Okay, we'll just leave it the way it is. Maybe there's no fillet here, but we'll just leave it just to save time. Okay, so let's do it on the other 3 tabs. Let's double check here, make sure everything else is okay. All right. Okay, so let's double click on edge fillet 3, or the last one that you created. Do the same thing for the other 3 tabs. And if you were to show this to a NC programmer, a machinist, they'll probably say, hey, we don't like your fillets. You need to go ahead and fix it because it's difficult to machine those fillets. Okay, so that just comes with experience, and also you can get the advice from a more experienced tool designer or machinist. And okay, there it is. All right, so now we're going to do the holes. So we're done with the fillets. Let's do holes now. Let's do these 4 holes first, which have a diameter of 12 millimeters. So 4 of them, diameter 12. Okay, so one thing I'm going to do is I'm going to pre-select the edge, the arc, so it'll center the hole. So click on the hole command. Click on surface, and we have a 12 millimeter diameter, and we're going to go up to last. It'll go the way through, and okay. There it is. All right, let me double click on these toolbars so they can be docked back where they belong. Okay, now let's mirror. So we can mirror this hole over to this side. Or you can do one hole at a time. It's up to you. Okay, so I'm going to use mirror. And we're going to mirror about the vertical. And there it is. It's giving us a preview, and okay. So there we have the two holes. All right, so let's mirror these two holes over to the other side. Okay, so we're going to mirror these two holes, this one and this one, over to the other side. Let's use mirror again. Now it's giving us an error message. It's telling us, hey, you cannot mirror a transformed element. In other words, you cannot mirror a mirrored element. Okay, so it gave us a warning, so I'm just going to cancel that. So since this hole was mirrored, you cannot mirror a mirrored element or a translated element. Okay, so we'll just do it manually, one at a time. So we'll do the same thing we did here on this side. Draw a hole here, or I should say create a hole. First select the arc so it centers it, and then click on the hole command, and okay. Okay, now we'll mirror that hole over to the other side. Let's go ahead and mirror at the vertical. There it is. And okay. All right, we have the 4 holes. There it is. Okay, so now let's go ahead and do the other 4 holes. This one's a little tricky. If we go to the original, so we're going to drill a hole because we have this bolt. Notice they're showing you a cut-off version of the bolt. It's actually a long bolt that goes all the way through. So they're not showing you the entire the length of the bolt. So they remove this portion. Notice there's holes in the screw, and there's slots in this castled hex nut. And that's so you can add a cotter pin so that the hex nut doesn't loosen up from this long bolt that goes through this hole and exits this hole. Okay, so to have a nice smooth surface made up with the bottom of the head of the bolt, we have to machine this to a nice clean surface. So we're going to drill a hole and do what's called a spot face, also referred to as a counterbore hole, but with a very slight touch, or you can see you're just barely kissing the surface to remove the rough surface due to the casting of the mold. So here are the diameters. So the diameter of this hole is 14 in diameter in millimeters, and the larger hole is 28 millimeters, and it has a very slight depth. You're just barely kissing the surface. So we can do a depth of, let's say, maybe 1 millimeter. And it's a spot face, meaning we're just removing enough surface to create a nice, plainer, smooth surface and not end up with the rough surface due to the casting in the mold. All right. Okay, so let's drill a hole. I'll pre-select this arc so it centers it. And we'll use the hole command. Click the surface. Okay, so we have a 14 millimeter diameter hole. Preview. Okay, now we're not going to go all the way through. We're only going to go through the first one. So I'm going to say up to next. So I'm just going to have it go through the first tab and hit preview. There it is. So it makes the other one disappear. All right, so now we're going to go to counterboard. So go to style and we're going to counterboard. So create a larger diameter hole over the little one. Counterboard. There it is. Okay, and the diameter, if we go back to our drawing, is 28. So this is the counterboard symbol. In this case, we're just doing a spot face. We're barely kissing off the surface to remove the rough area to accommodate the head of this bolt. Okay, so diameter of 28. and preview. Notice it's cutting through, but we don't want to go that deep. We're just going to kiss it. So we're going to put a depth of 1 millimeter. And okay. Notice it just removed part of the rough area. If you want to go 1/2 millimeter, go for it. Okay, so we're just kissing off the rough surface due to the casting. Now I'm going to go down to 1/2 millimeter. I'm going to go back to the whole command. Go to the type tab, depth, I'm going to go 0.5. Preview. Yeah, that looks a lot better. And okay. A lot cleaner. Okay, so this is referred to as a spot face or a counterbore hole. Okay, so I'm going to repeat the same thing. Okay, so I'm going to do the exact same thing on this side, and it should use the default measurements I used earlier, the default diameter and depth. So I'm going to pre-select the arc, click the hole command, click on surface, and there it is. It remembers the last inputs, and there it is. Okay. Okay, now what I can do is mirror these two. I'm going to pre-select the two holes, and I'm going to mirror them over to the opposite side. Okay, so let's use mirror, and we're going to mirror about the vertical, the ZX plane. It's already given us a preview, and okay. There we go. We have our spot face and holes. All right, and once again, don't worry about the fillets. If your fillets look different than what I modeled up, it's okay. We can spend a whole semester just talking about fillets. And again, fillets, it takes experience to know how to fillet edges, especially when there's curvature involved. And it also, you need to have some machine shop experience or NC programming experience. NC programmer for machine shop will tell you if it can be done or not, or they'll advise you on how to fix that. All right, so that was the base plate. So let's right click on the part, right click properties, and let's give it a name, base plate. Okay, and let's move on to the other parts, which will be a lot easier. Okay, so we're done with the base plate. All right, so let's move on to the next part. Okay, so let's do the bracket. This is very simple. We'll do an L bracket shape. Okay, so this bracket has a measurement of 44 by 32 and a thickness of 5. Okay, so we're going to make an L shape of 44 by 32. Okay, if you want, go ahead and save your base plate. I'm going to create a new file, or you can just go to Start, Mechanical Design, Part Design. Even though we are already in the Part Design workbench, if we click on it again, CATIA assumes you're going to start a new part. Okay, so if I go to Part Design Workbench, even though we're already in it, as you can see, CATIA knows to create a new part, as you can see, and okay. Now I did not lose my base plate. I can always go back to it, just go to the drop-down window, to window drop-down, and you can go back to base plate. So I currently have 2 sessions open. If I go vertical, you can see both sessions. Okay, notice this is blue, letting me know this window's active. If I click on this one, it'll turn blue, and now this one's active. Okay, you can either maximize here or double click on the frame to maximize that window. Okay, so we're going to draw an L shape. So let's sketch. I'll sketch on a vertical. I'll pick the ZX plane. It doesn't matter which one. Create a sketch, and I'm going to draw an L shape. Now you can continue on and close the profile. I'm just going to do 2 lines, and I'm going to escape and exit. Okay, and I'm going to add my measurements. So let's go back. Measurements are 44 and 32. Okay, 44 for the horizontal. 32 for the vertical. Okay, so the rule to follow is to do a close profile, right? We want to close it. But we're going to cheat. We can get away with not using a close profile and still use pad. Okay, so let's exit the sketch. That's all we needed. Tool sketch analysis. It's going to warn us, hey, this is opened. It's not closed. And I want you to notice that in cyan, it shows us where the mistake is at. It's telling us, hey, there's a gap or there's an overlap. Okay, I'm going to ignore it. I'm going to exit the sketch. Okay, now I'm going to do a pad. And when I do a pad, it's going to give me an error message saying, hey, this is not a close profile. But you know what? If you pick the thick option to thicken it, then we'll accept it and say, yes, we are going to thicken it. All right, so let's first get the length of this bracket. So the overall length is 260 and it has a thickness of 5. So 260 for the length. Okay, so for the length, we're going to go 260 and preview. And it's still warning us, hey, this is not a close profile. You need to use thicken. Okay, so I'll hit OK. So here's the thick option. So click on the thick option. And for thickness, we're going to go 5. So you can thicken in two directions, inward or outward. Okay, so let's thicken this to 5. It's going inward. That's what we wanted. Okay, you can always thicken in two directions. We're going to go inward as far as the thickening. We can also go outward, as you can see, but we're not going outward. I'm going to go back to 0. Preview, and there it is. And OK. Okay, we got the difficult part done. All right, so let's go ahead and add some sketches. Okay, so let's go ahead and sketch this one on the top surface. Okay, we'll do a slot and we'll do the holes. But we're missing something. We're missing the radii of 16. Okay, so let's first do the radii. So this one up here is 16. The one on the bottom is 14. Okay, so let's go. Typically, when you do like these 4 corners with fillets, typically you want to keep it the same. In this case, they're not. So one pair is 16. Fillet this corner, and this corner was 16. Type in 16 for your radius. There it is. And for the bottom, we're going to go with 4. My mistake, 14. Okay, 14, not 16. And okay, there it is. Okay, so now let's go ahead and do our sketch up here. Now, typically we want to do it on a plane. We don't have a choice here, so we'll use the surface. Okay, so we do have a slot and we have 2 holes. Now they do line up with the fillets here. Okay, so let's start with the elongated hole. One of my favorite commands, right? So we'll do an elongated hole and then we'll put a constraint with the arc. Okay, I'll worry about the dimensions later. Now I accidentally added a constraint that I did need. It's making a tangent to this one. So it generated a constraint I didn't need. Let me darken this just so you can see it. So it generated a tangency constraint, as you can see, which I didn't want. So we can go to the constraints tree, and it's the last constraint here. So I'm going to just right click and delete it. Okay, so I'm trying to keep this hole separate from the slot, or else it would have moved with it. Now there is a relationship between the hole and the slot, but we're going to go ahead and just constrain them to the arcs. Let me go back and bring back the solid. Okay, so I'm going to add a relationship between this circle and the arc. Hold on to the control key, click on the arc, and we're going to make it concentric. There it is. So now the hole is centered with the arc, and we're going to do the same thing with the slot. Pick this arc, hold on to the control key, hit the arc, click the arc, and concentricity, and OK. All right. And we have another hole. Now we do want to line it up with this one, so I do want to track. I want you to notice that this hole, if I grab it by the center, it's constrained to this one. At least it appears it is, or else it's constrained to this line. Oh, I didn't constrain it. It tracked this point, but it actually constrained it to this center line, which is fine, because I think these two holes are centered about this line of the elongated hole. All right, so let's go get some measurements. Let me go ahead and turn this just so I can match the drawing. All right, so elongated hole. It has a radius. So what is the radius? Well, it's just half of 10, which is 5. Okay, so they're giving us this distance instead of the radius. They do have a relationship because these horizontal lines are tangent to the ends of the arcs, and the arcs are 180. And the radii, or diameter, I should say, of the holes are 10. So it just happens that the arcs are the same size as the holes. And then we have this distance of 26. And the elongated hole is 102. Okay, so the length is 26. My mistake, 102 for the slot. And for the distance between the holes, it's 26. So we'll go center to center, dimensional. And we have diameters of 10. Okay, so diameter of 10. And diameter of 10 for the other one also. And OK. All right, so, and let's take a look at the radius here, which is 5, half of 10. So let's change this to 5. And there it is. Do a tool sketch analysis. Everything is closed. Good. And we'll do our pocket. Okay, let me just double check the dimensions. Yep, 102, 26, and 10. All right, so let's exit and do a pocket. And up to last. And OK. And there it is. Okay, so now we need to do our sketch for this wall here. Okay, so we have a slot. Okay, so this slot isn't lined up with the arc. It should have been. It's probably a mistake on my end, but it's okay. We'll just follow the dimensions here. If your dimensions are off, again, I'm not going to take any points off. Okay, so we have a distance of 18 from this edge. And this slot is 12. And from the edge to the center is 18 also. Just like this 18. And the slot size is 12 and 160 in length. All right. So let's do a sketch on this surface. But you know what? If we have a plane, let's do the plane. I'll pick the plane instead. Do our sketch. Okay, so we'll do a elongated hole once again. Okay, so let's take a look at trying to grab the. So we know the size of the slot is 12. Cut it in half, so the radius is 6. There it is. And we have a distance of 18 from the top edge to this horizontal. Okay, so 18. And 18 from the edge, vertical edge, to the center of the slot. There it is, 18. I forgot the length of the slot. Let's go back. Okay, length of the slot is 160. Okay, it looks good. Let's do a tool sketch analysis. Everything's closed, everything's good. And let's exit and do a pocket up to last and okay. And there it is. We're done with our bracket. Okay, I don't think we missed anything. Got all the features. Oh, I'm missing the radius of 2. So we have a fillet here of 2. And actually along the inside edges. So all the inside edges have a fillet of 2. Okay, so let's do a fillet here first of 2. Okay, so 2 radii or radius and okay. All right, so let's double click and let's add more. Let's see if it'll let me add this edge. Let me hit OK, see if it'll accept it. Okay, notice how it does a turn here. So I'm going to do it in steps. I'm going to remove the second edge that I chose. I'm going to remove this one by selecting it and only keep the original one, the one edge that we selected. So I want you to notice that we're going to get a different result when I do a second edge fillet. So I'm going to do a second edge fillet. And by clicking this edge, it's going to go all the way around. Notice it follows tangency because that's the default. And preview and hit OK. Notice how we get a different result by doing 2 separate edge fillet operations versus 1. It'll give you a different result. So if we go back, I can click define, go back here. And just to show you again what would happen if I select the second edge under the same edge fillet operation. Notice it'll give you a different looking fillet. Okay. Now the second fillet can't exist because it's going to clash with this one. So I'm just going to hit undo. So we can go back to where we were. There it is. And to come back to the present, right click on the part body and define. There it is. Okay, so we're done with this part. Let's go ahead and give it a name. Right click properties. Okay, and we'll call it bracket. And okay. You know what? Let's give it some color. You don't have to do this part, but it's good practice. Right click properties. Go to graphic tab. I'm going to give it some color. Let's go to more colors. And I'm going to pick, it's good to pick soft colors. Soft colors for the large pieces and bright colors for the small pieces, like the hardware. Okay, so give it some color. I'm going to go back to my base plate and give it color. Right click properties. Pick whatever color you want. If you want to make it yellow, keep in mind it's going to be bright. It's going to be an eyesore. I'm going to give it a purplish color. Nice soft color. Okay. All right, so now let's move on to the next part. Okay, which is the support. All right, so there's different ways of doing this. I'm going to use profile. We can also draw circles and then connect the circles with lines for our sketch. Okay, so we're going to start by first drawing this wall or this flange, and then we'll come back and do the bosses. Okay, let's do this sketch, and it has a pad or thickness of 8. All right, so I'm going to do a rough sketch first. And I'm gonna have the origin here at 0, 0. All right, so let's start with this simple sketch. Okay, so let's go to start again, mechanical design, part design, and even though we are in part design, when we click it again, CATIA knows that you want a new part. Okay. Okay, and I'm going to pick a vertical plane. I'll pick the YZ plane, do a sketch. And again, I want the main hole here at the origin. All right, so I'm going to use profile. Okay, so use profile. And let's go ahead and start. So I'm just going to guesstimate. I'm just going to work my way around. Just going to guesstimate here. So we have a hole here. Click, there's our line, and then I'm going to go arc. So I have an arc here. Again, I'm just going to guesstimate the shape, and I can always fix it later. I want tangency. Click, arc. I'm going to intentionally do it all messed up. Click. And another arc. And then we'll come back and add our constraints. And let's close it off. There it is. Okay, you can see this is a very rough sketch. All right, so first, and look, I'm missing a tangency, as you can see. I was to grab to this corner. And we can clearly see it there. All right, so I'm going to start by making this arc centered about the origin. So here's that point. See there's that point for this arc. That's the center. But let's see if I can put concentricity between the origin and the arc. So I'm going to hold on to the control key on the keyboard. Select the origin, the arc, and go to constraints. Oh, it does allow me to add concentricity. I wasn't sure if it would. There it is. Okay, so I pre-selected the origin and the arc and went to concentricity constraint. Okay, this should be vertical, so I'll make this one vertical. And okay, and this one should be horizontal. Let's add a horizontal constraint. And okay. And we need to add a tangency constraint between this line and the arc. Hold on to the control key when you select the two elements, and let's add tangency. And check that we have tangency all the way around, and yes we do. Okay, so now let's throw in some dimensions. All right, so this has a diameter of 36. So the radius is 18, half of 36 is 18. And these circles here have diameters of 20. Cut that in half, and that's a radius of 10. Okay, so 18 and 10. Oh, that's a very large radius, so it may really shift our sketch. Okay, so this is 18. Let's see what happens. 18. Don't worry if our sketch goes flying because of this drastic change from almost 70 down to 18. And okay. All right, okay, not that bad. All right, not that bad. Now let's do the smaller ones, which have radii of 10. Okay, not bad. Let's do the other one. Also 10. Whoa, it went flying. It's okay. You can always grab, since it's not fully completely constrained, we can just grab it and adjust it, as you can see. We can adjust it. Whoa, it's not, you don't want to do something that drastic, but don't be afraid to grab onto the geometry and slowly pull, see what happens to it. And we can readjust it. That looks about right. Let's zoom in. Okay, so now we need some overall lengths from center to center. And again, I'm emphasizing that this arc is center with the origin. Later on, it'll be easier when we do the other features on this part. All right, so we have a distance of 76, center to center, and 32, center to center. Oh, and I have a mistake. This is not vertical. So I'm gonna have to come back and fix this. I'll remove the vertical constraint. Okay, so 32 and 76. Okay, so let's remove this vertical. I'm gonna hit delete on the keyboard. There it is, it's gone. And now I can, so you can see, adjust it. Okay, so now let's put a dimension from center to center. It was 72, I believe. And okay, and then we have a dimension from the horizontal, which happens to cross the center point of the arc, to this center. And I forgot the dimension. 32. Oh, so it's 76 and 32. and 76. All right. Now we have this dimension of 4. So from this vertical here to this point is 4. Okay, so let's go ahead and add that one. Okay, so you have two options. You can either go to the vertical, which happens to cross the center of the arc to this point, and change it to 4. Another option is, let me delete it. Let's go center to center, center to center, but notice it's not giving me a horizontal dimension. You can force it horizontally. You can just right click and say, hey, I want a horizontal dimension. There it is. 4. There it is, and it's completely constrained. It's green. We're good. Okay, let's do a tool sketch analysis. Make sure everything looks good. It's closed. Okay, let's go ahead and exit. And let's do our pad. I think it has a thickness of 8. So let's do a pad of 4 in each direction. I want to keep it symmetrical. So let's change this to 4. Preview, and then we'll mirror it. So it goes 4 in the opposite. Preview, there it is, and okay. Okay, so there's the main part of that support. Okay, and yes, it's 8, so we went 4 in each direction. Okay, so now we're going to do the bosses. Okay, so we're going to draw circles. So we're going to create another sketch and create these circles and this circle with the flat top. Okay, so let's go back. All right, so I'm going to sketch on, you can do it on the surface. I prefer to do it on the plane, which is in the neutral position with respect to the thickness of this wall. Okay, so let's do a sketch on that plane. Okay, so I'm going to create a circle. I'll just guesstimate for now. We have a circle here, circle there, and a circle centered with this one. All right, so we're gonna put a coincidence constraint between the arcs and the circles. So hold on to the control key, select the arc, and put a coincidence. And notice it takes care of the position and the size. Okay, so hold on to the control key, hit the arc, click the circle, and put a coincidence. And it centers it, and it also takes care of the size for us. Do the same thing with this one. And coincidence, and okay. And there it is. So we have our 3 circles. Do a tool, sketch analysis. Everything's closed. And we can exit. All right, so let's take a look at the bosses here. Notice they don't have the same thickness. This one has a thickness of 26 and this one has a thickness of 12. All right, so 12 and 26. So 12, 12, and 26 for the thicknesses. Okay, so instead of doing a pad, we're gonna do a multi-pad. Okay, so let's go to multi-pad here. So click on multi-pad and let's select the sketch. All right, so we're gonna do a pad of 12 and preview. My mistake, I gotta do it here. Click here, we're gonna give it a thickness of 12. Oh, I picked the wrong one. That one has a thickness of 26, or I should say 13 because we're gonna mirror it. Let's see if we have a more option here. There it is. So we can also go 13 in the opposite direction. Did not have a mirror, so I'll just manually type in 13. Preview. There it is. Total of 26. Now let's go to the next one. So the next one, we're going to go 6 in each direction. And preview. There it is. Total of 12. And finally, the last one. Same thing. We're going to go 6 in one direction and 6 in the opposite for a total of 12. Preview. And there we have it. There's our bosses. And okay. Now, one mistake I did do is I forgot the flat top, right? Forgot to include the flat top on this lower one. So let's go back and fix that. It's okay. Completely missed it. Let's go back to the sketch. Okay, so we need to add a flat top here. So I'm going to draw a line going across and then on the circle. Make sure it's horizontal. And there it is. Okay, so make sure that the endpoints land on the circle. Same thing with this one. All right, so we need a dimension here to locate this, and then we'll erase the top portion. So this horizontal line is missing a dimension. Okay, and that dimension is 15. Okay, so dimensional constraint from the horizontal to the horizontal axis. And 15. And there it is. There's the flat top, and we need to remove this portion. Okay, so we're just going to simply use the eraser, quick trim, to remove the top portion. And there it is. So we have our flat top. Do a tool sketch analysis again. Everything is closed. Okay, close it. Exit, and your patch should update. There it is. It turned red, letting us know it was updating, and it did. All right. Okay, tough part is done. Okay, now fillets. Fillets are a nightmare. So the fillets are a nightmare. So I'll leave that up to you if you want to fillet this object. Okay, so we have fillets of 2. So typical, radius of 2. Okay, so all the rounds are 2. But before we do, I forgot to add this little boss. Luckily, we have this hole centered about the origins, so that'll help us create the surface here, or this pad here. All right, so we're gonna do a pad with the vertical plane here, and we're gonna sketch it looking this way, looking horizontally on the vertical plane here. So we're gonna draw a diameter of 16. Okay, so let's go back. So on this vertical plane, in this case the ZX plane, I'm going to draw a sketch. Okay, and I'm going to make a circle of 16. And again, we're using that same origin. Okay, and diameter of 16. Okay, notice the sketch is in this vertical. Now the pad is out here, but that's okay. We'll come back and fix that. And exit. Okay, so now we're going to do a pad of this circle. We'll do a simple pad. And I don't know the dimension. I'll have to go back and look at it. Let's just do a preview here. Okay, there it is. There's our pad. Hit OK. And there's the pad. Okay, obviously it's too long, but let's go and see the dimension here. Okay, and that's 20. So the pad is 20. So let's go back to the pad and change it to 20 and enter. And there it is. All right, so just a warning, you are going to have trouble with fillets. I may have trouble with fillets. It's the most difficult thing about modeling is filleting. Okay, so I'm just going to pick this surface and fill it all the way around. So I'm going to go ahead and do a fillet. Let's dock this back into place. Fillet, pick this surface. So it'll pick all the edges. Let's see what we get, and OK. And error, it didn't like it. Okay, that's fine. Hey, do you want us to compute it? Yes, sure. Nope. Okay, so do you want to keep explicit edges? Let me say yes. I think what's causing the problem are these two edges. Let's see what happens when I say, hey, keep these two edges. Let's see what happens. Notice it's a light purple or magenta color. So where it says keep edges, so it's not going to try and fillet this portion. Let's see if it'll allow it to. Preview. And it looks like it did accept it. Close. Oh, and obviously the fillets are way too large. That could have been another reason for the error message. So the default was 5. I changed it to 2. And it did accept it. Okay. So edges to keep. So that worked. Now let's do the same thing on the other side. I'll do it as a separate operation and fillet. Let's see if it accepts it. Hit OK. And this time it did work without having to pick the edges to keep. So in the previous one, the fillets were initially too large. And I chose edges to keep. Let's see what happens if I go back and remove those edges from the first fillet. I'm going to deselect them. I'm going to remove them. Oh, my mistake. Cancel. Go back. And I'll just remove them here from the list. Remove. Remove. See if it'll accept it. Removing the edges to keep. OK. And it did accept it. Notice how we get a funny one for this one. And so this is very common. Even though it's a mirror image, notice how the fillet on this side looks different from this side. And it's the way it generated the fillets. Maybe it started on one edge for one and it started a different edge on the other one. Okay, we can go in circles trying to fix this. I'm just going to leave it alone. I'm just going to let it be. All right, so now let's try and put a fillet around this one. See if it accepts it. Okay, did accept it. All right. Okay, I'm not going to try and go back and try and figure out why this didn't work. I can spend quite a few minutes or maybe an hour trying to figure it out. I'll just leave it alone. All right, so let's look for more fillets. Okay, I think we got all the fillets. All right, if I missed any, that's okay. Let's just move on. All right, so now let's draw the holes or create the holes. We have a 25 diameter, 12 diameter, and this one is a threaded hole. So it's M is for metric system. So we have an M10, meaning a 10 millimeter diameter threaded hole. So this is a tapped hole. It has threads. We never model threads because it eats up a lot of memory. So we'll just do it as a plain 10 millimeter diameter hole. Okay, so let's go and place the holes into this part. Okay, let's do the 10 millimeter one first. Okay, so I'm going to pre-select the edge. And we're going to drill a hole through the surface of 10 millimeters. And you know what? I'll just go about halfway. I'm just going to, you know what? Oh, my mistake. 10 millimeter diameter. I'm going to say I'm going to go up to this plane. So I'm going to say, hey, I want to drill that hole up to a plane. And okay. Okay, so we drilled a hole up to that plane, as you can see. And then later on, we're going to drill a hole here. Let's do the 12 diameter ones. So I'm going to select this boss, the edge of that boss. And we're going to put a 12 diameter hole and up to last. Okay. Oh, let me dock this back in place. There it is. Do the same thing with this one. Select the arc, hole command, surface, 12 diameter, hole, and let's go up to last. That'll go through the entire material. And finally, the large hole, forgot the diameter, is 25. So you can click the hole command and then click the edge, the arc. It'll center it. There it is, and 25 diameter up to last. Okay, there it is. Notice it took care of this hole, which is fine. So this is a threaded hole where a set screw, it's just a screw with no head. And the reason it doesn't have a head is so that we don't over tighten it. Okay, and these are just smooth, simple holes. All right, so let's double check, make sure I didn't forget anything. Looks like we got it all. All right, so let's name it support and give it a color. Okay, right click properties. Let's go ahead and give it a name, product, support, and okay. Oh, I forgot to give it color. Right click, properties, go to graphic. Oh, my mistake, I need to right click on the part body. Let me close. Right click on the part body, properties, and that'll allow me to give it color. Go to the graphics tab. I'll make this tan or light brown. There it is. All right, so we're almost there. Okay, so let's go to the next drawing. Okay, so now we're going to draw a shaft and then we'll do the knuckles. So these are pretty easy. So we'll draw a shaft. Let's see, this has a diameter of 25. Okay, so let's go to start once again. Mechanical design, part design. We could have gone to file new. Let's go that way. Let's go to file, new. But now we have to go down to part and okay. And okay. All right, so let's go ahead and draw a sketch on any of the planes. I'll pick this vertical plane, the ZX plane, and let's do a sketch of a circle. I believe it was 25 in diameter. And okay. And we don't have to do a sketch analysis. Let's go ahead and exit. And let's do a pad, and we're gonna do a mirror pad, okay? Okay, so we went with the diameter of 25. The length is 204. Cut that in half. So we go 102 in each direction. 102 in each direction. Normal to the sketch. Okay, so pad, sketch, 102, 102, preview. And let's use the mirrored option. And okay. All right, so now we need to add some holes. Okay, so the holes, diameter of 19, depth 14. Diameter 19, depth 14. Okay, so I'm going to pre-select the edge of the cylinder. Go to hole command, so that way it'll center it. Click the surface. So we have a diameter of 19 and a depth of 14. And okay. There it is. And repeat on the other side. You can hit Hold Command and then select the edge. As long as it's an arc or circular, it'll center it. And it remembers the last input. And OK. And we have chamfers going around the edges. We have chamfers. Let's take a look at that chamfer. OK, chamfer, 2 millimeters by 45. So here we have the chamfers, 2 by 45. 2 millimeters by 45 degrees. Okay, so I'm going to pre-select the edge. And we're going to do a chamfer. Okay, so it's 2 millimeters, angle of 45, preview. And OK, there's our chamfer. Okay, we can always go back and create a second chamfer. We can just double click on the first one and select a second edge. So it'll do both of them. So it'll do both edges with under one command of chamfer instance 1. So we don't have to do a second chamfer. We can do it all in one shot. Okay, and there it is. Okay, so let's go ahead and give it a name. So right click properties, product, we'll call it shaft. And let's give it some color. Right click properties. Okay, go to graphic. So right click on part body, go to graphic. And again, let's give it a smooth color. Okay, I'll use blue. And OK, and there it is. All right, if you want, you can go ahead and save it. Let's go on to the next part, which is the knuckle. Okay, so the knuckle, to make it easy, what we're going to do is we're going to sketch about the origin. So what we're going to do is we're going to draw half the profile. We'll draw half the profile when we do the spherical portion. So first we'll start with the rectangular sketch, do a pad, and then we'll come back and do a profile of the spherical portion and do a revolve or a shaft command. Okay, so let's start with a 20 by 20 rectangle. Okay, so once again, go to Start, Mechanical Design, Part Design. Okay. Let's do a sketch on one of the vertical planes. I'll pick the YZ plane. Do a sketch. Okay, and we're going to do a centered rectangle. I'm going to do a centered rectangle about the origin. Okay, so once again, centered rectangle about the origin. And it's 20 by 20. Okay, 20 by 20. Oh, and I missed something. Somehow this dimension. Whoa, I didn't pick the origin. Okay, so I need to constrain it with the vertical. So I misclicked. I didn't exactly pick the origin. So what I'm going to do is pick the center point here of the rectangle. Hold on to the control key and make it coincident to the vertical. So it did end up being coincident to the horizontal, but not the vertical. I just slightly misclicked. So let me fix that. And there it is. All right, so now let's go ahead and do a pad. Okay, so exit. Do a sketch analysis first. Pretty sure everything is fine. And let's do a pad of 10 in each direction. And do mirrored. And there's our cube, our 20 by 20 by 20 cube. Okay, next thing we're going to do is our spherical portion. Okay, so I'm going to pick a vertical plane. Okay, I'll pick the YZ plane to do our sketch of the spherical portion. Okay, this is going to be a little bit tough. All right, so I'll start with profile. I'm just going to do a rough sketch of the spherical part. So I'm going to start with the vertical, which later I'm going to line up with this edge. Okay, so I'm going to start with the vertical. Click, and then I'm going to do a arc. As you can see, I'm already creating the profile. Click. And then I'm going to do another arc, tangent to that one. Okay, And I'm trying to pick the horizontal. So I only need to draw half of the profile. So I'm gonna constrain it so it lands on the horizontal axis, and it'll constrain it. There it is, and hit escape. So there's a rough sketch of our profile, and click and space to deselect. Okay, now this edge is just construction. Okay, so I'm going to select it, turn it to a construction element. There it is. Then turn off construction, turn it off. Okay, now I'm going to make this edge, hold on to the control key, coincident with this edge of the solid. Put a coincidence constraint. There it is. Okay, now I'm going to take the center of the arc. See, here's the center of the arc. And I'm going to make it coincidence to the horizontal. Hold on to the control key. So while holding on to the control key, select the center of the arc and the horizontal. Make it coincident. Okay, there it is. All right, so now let's add some radii. And I should say some radii, plural for radius. Okay. Okay, so we have a radius of 4 and a diameter of 18. Cut it in half, radius is 9. So 4 and 9. Okay, so add a radius of 4 for the little one. And a radius of 9 for the large. Whoa, my mistake, clicked the wrong command. There it is, dimensional constraint of 9. All right, so something is still off. Okay, looks like I'm missing notice I can move it left and right. So I'm missing a horizontal. So most likely I'm missing a dimension from the center of the sphere to the vertical or to the wall. Let's look for it. There it is, 24. So 24 from the center here to the center there. Let's go back. Okay, so dimensional constraint from the center. So I'll pick the vertical axis to the center of the arc. And that's 24. And okay. All right, so we're going to do a tool sketch analysis. It's going to give us a warning. Hey, this is an open profile. You can see the cyan circles, letting us know it's open. Those are the endpoints. We're going to accept it. All right, so let's go ahead and exit. Okay, so now I'm going to do a revolve. If it refuses to do the revolve or the shaft, I'm going to have to go in and close the profile. Let's try it without closing it, see if it'll work. Okay, so I'm going to select the sketch and do the shaft command or revolve. Seems to accept it. Okay, we're going to rotate it about the horizontal axis of our sketch. Okay, another option is to rotate it about an axis. So we can rotate it about the y-axis. The y-axis is right here. This is the y, the z, and the x. Okay, so you have the option of picking the y-axis. Okay, watch what happens. Y-axis gives us a preview. Okay, and we're going to rotate it 360. Again, another option for axis could have been the horizontal axis of our sketch. You can pick it from here, or we could have picked it from the tree, the horizontal. And okay, and there it is. That's how you do our knuckle. Okay, so now let's do the hole. So we'll draw a circle on this sketch. Okay, so let's draw our circle for the hole here. And I believe it was 12. I'll go back and check. So this is a threaded hole. And M12, M stands for metric system. So this is a 12 millimeter diameter threaded hole. That's the major diameter of the threads. And the 1.75 tells us how far the threads are, how far apart they are. This is referred to as the pitch of the threads. All right, so let's go back. So we're not going to model threads. We're just going to do a simple hole and exit. And we'll do a pocket. Okay, so let's do a pocket. And we'll go up to last. And we're going to also have to go in the opposite direction. So we'll go to the second. So go to more. So we can also go up to last in the other direction. And okay. And the hole goes all the way through. Okay, so that's the knuckle. It's probably going to be the most difficult part. A lot of students get stuck on this one. That's why I wanted to model it, show you step by step how to do it. You can get lost trying to create the spherical part. All right, so let's give it a name. Okay, so this is referred to as the knuckle because it looks like part of your knuckles, right? Looks like one of your knuckles, so. Okay, and let's give it a color. So I right click on the part body. Let's make this a little brighter than the others. Graphics tab. Don't make it too bright. More colors. Okay, I'll pick a lighter color. Doesn't really matter. All right, so now if we go back to the original, I want you to notice that the knuckles have rounded edges. Look at this note here. Here you do see the threads. Again, we don't model threads. So this is an M12 thread, meaning the diameter is 12 millimeters for the major diameter. And the threads are 1.75 millimeters apart. That's the pitch for the threads. And we have radius of 6 at the corners. Okay, so if you want to do that, if you want to do the radii, or the fillets, I should say, at the corners, let me show you real quick how to do it. All right, so I'm going to start by measuring diagonally across. I'm going to need that measurement. So diagonally across, I'm going to go from this corner to this corner. So diagonally, that's about 34.5. I'm going to just round it downward to 34. Okay, cancel. All right, so here's what I'm going to do. I'm going to do a sketch to round off this corner. There's a faster way of doing this if we were to use surfacing, generative shape design workbench, but some of you or most of you have not taken that class. Okay, so I'm going to have to do it the long way. I'm going to do a sketch on this vertical plane, on the YZ plane. And I'm going to draw a circle at 34 in diameter. Okay, remember the diagonal measurement was just over 34. I'll just round it down to 34. All right, so again, we're trying to round off the corners. So what I'm going to do is I'm going to rotate this sketch to remove the sharp corners. Okay. All right, so let me go ahead and hit normal. All right, so what I'm going to do is I'm going to change this to a construction element. Then I'm going to draw a little sketch here, a little profile to take care of these sharp corners. Okay, so here we go. So I'm going to draw the simple profile and then I'll move it over here. Oh, I forgot to turn off construction. Let me turn it off. There it is, turn off construction. Forgot to turn it off. Okay, and then I'm going to draw an arc. Okay, so notice when I did the arc, I clicked. So when I went to arc, I clicked to define my arc. All right, so let's give it some lengths. The lengths are not that important. We're just gonna break the corners so they're not sharp. It's not a big deal. I'll make them 4 for both of them. Doesn't really matter. Okay, and I'm gonna make the arc tangent to the horizontal. Put a tangency constraint, and I'll do the same for the vertical and the arc. Place a tangency. So I'm over dimension, so I'll remove this one. So the 4 and the 4 are fighting each other along with the tangencies. So I can just remove one of the 4s and delete it. All right, so, and I'm gonna give it a radius. Let's give the arc the radius of 6. Oh, so I don't need this 4 either, because now these two are fighting. Let's go ahead and remove this one and change this to a radius of 6. And okay. Okay, so now I'm going to move this over. Now, one thing I do want is for this to be in line with the origin. So I'm going to draw a line, a construction line. So go to construction, draw a line. And again, this profile is optional. You don't have to do this, but in case some of you were wondering, there it is. I drew a line, construction line, and then I'm going to make it symmetrical with these two. So I'm going to hold on to the control key, select the horizontal, the vertical, and then this new line, select it last, and put a symmetry constraint. There it is. Hit OK. Just go normal. All right, so now this line, I'm going to give it an angle of 45. Hopefully it won't be over constrained. Oh, yes it is. So I'm going to have to remove the symmetry. So change this to 45. Okay. Let's see if I need the symmetry. I'm going to delete the symmetry. There it is. Oh, so I misclicked here with this line. Once again, I missed the origin. See this line here is supposed to line up with the horizontal, which it is, and the vertical. So let me add a constraint between this endpoint of this line. Hold on to the control key, the vertical, and put a coincidence. There it is. And that's what I wanted. So I want to be able to adjust this. Now I'm just guesstimating on the revolve we're going to do. Okay, so I really don't know where to position this. So I'm going to just get it close to this 34 diameter circle. Okay, and then I'll come back and constrain it. So let me first see if it'll work. Okay, so I'm going to exit. Okay, exit the sketch, and then I'm going to revolve it using the groove command. Okay, and I'm going to revolve it about its H or the y-axis. Okay, or the horizontal axis. Okay, so let's do so I'm going to pre-select the sketch, do a groove. Okay, and I'm going to select the horizontal axis of the sketch. And as you can see, it's cutting through the corners. And okay. Notice it only cut through a portion of it. Okay, so let's get the preview. So see the sketch is cutting through, as you can see. So I need to take the sketch and just pull it outward a little bit so it eats up the other portion. And okay. Okay, so let's adjust our sketch. Stick it a little bit outward some more. Let's exit. And now you can see it's rounding off the corners. All right, so what I'm going to do now is I'm going to mirror the other side. So go to sketch, and I'm going to mirror this. selected, and we're going to mirror it about the vertical. And if we want, we can put a dimension now on this line. There it is, it's green. Well, I'll make it 20. See if that works, 20. Now we can always come back and adjust it and exit. And it has removed the sharp corners. I can go back and adjust it. It's not exactly what I was looking for, but at least it broke the corners. The actual way of doing this, I'm going to show you guys real quick. The best way to do it is to go to Generative Shape Design. Again, we haven't taken a CAD 37. This is surfacing. What I would do is I would draw a sphere. So first I would place a point at 0, 0. Okay, place a point at 0, 0. And I would draw a sphere. And this is just surfaces about that point. Oh, it actually defaults to the origin, and pick the sphere option and reduce the size of that sphere. And then I would chop off those corners with the sphere. That's what I would do. Okay, so this would be the right way of doing it. Okay, so let me undo a few times. This would be the correct way of doing it, but we don't cover surfacing in this class. All right, so let's go back to our drawing. All right, so we have our knuckles now created. And finally, we have the hardware. So I will include in the email the hardware, the bolts, nuts. You can model your own, or you can also download them from the catalog in CATIA. And I'll go over that in a few minutes. All right, so what? It's bothering me that this doesn't look right. Let me go back to our sketch. What I'm going to do is remove this radius. I'm going to give it a radius of 34. Or actually 20. Remove this length. And just pull it outward. Oh yeah, that's way too much. 20 is way too much. Let me use 10. Exit, see if it accepts it. Ah, that looks cleaner. Okay, way better. Okay, so let's go back to the sketch. So what I did is I changed this to a radius of 10. 6 was just way too small. And now we can add a length here. And again, we're just guesstimating. I'll change it to 20.5. Just didn't look right, so let's see if this looks better. Yep, so we rounded off the corners. All right, so now let's go ahead and assemble this. Okay, so we're gonna go with start, and we're gonna create an assembly. Go to assembly design. It'll take you to a assembly window. Okay, now I'm gonna go window vertical. We can see all our items. So once again, if you want to see all your items that you modeled, go to window vertical. It'll give you a window of each item that you modeled, including our new assembly window, which is still empty. Okay, so I'm going to start by dropping the base plate. Okay, I'm going to drag and drop. So left mouse click, hold, and drag it and drop it into the product. That's one option. Okay, don't try and drag a large assembly into another assembly. It'll eat up a lot of memory, and it may end up freezing up your computer. Okay, so I'm just going to drag and drop these items. Okay, so I'm going to go ahead and now drag in the support. Oh, I misclicked. Try it again. Left mouse click, hold, drag and drop. Okay, let's do the bracket. Left mouse click, hold, drag and drop. I'll do the shaft. Left mouse click, drag and drop. And finally the knuckle. Left mouse click, hold, and drag and drop. Okay, so another way of doing it is by inserting existing component, right? Now, you haven't saved it yet, so you would have to save these files first before you can use existing component. All right, so let's maximize our assembly. Double click on the frame or hit the maximize button. There it is. Okay, so we are to make assemblies. Okay, so if we go back to our handout, we're going to create sub-assemblies. Okay, notice the little red. I'm going to hit the branch here so I can, it's already at max. Hit the branch to exit tree mode. There it is. You can always hit the little white axis here at the bottom right corner to exit the tree. All right, so these little red axes tell us that these are individual components. So we need to create sub-assemblies. If we go back to our drawing, let's go to the beginning. We have our top assembly, and we have these individual smaller sub-assemblies. Okay, so let's create the shaft sub-assembly first. Shaft sub-assembly. It's the shaft and two knuckles. Okay, so we're going to create the shaft assembly. So to add a new assembly inside, we're going to go to product here. So we're going to create an assembly inside of this main assembly. Let's first give this main assembly a name. And let's call it the top motor base assembly. And okay, there it is. All right, so now we're going to add an assembly inside of this top motor base assembly. So click on this option, product. So you're telling CATIA we're going to insert, again, think of it as adding a binder to your backpack. So right now you just threw all these items inside of your backpack, but now we're going to organize ourselves and we're going to include a binder in our backpack. Notice it doesn't have the red axis, letting us know this is a binder or a assembly inside of the main assembly. And these are just individual pieces, and we can see by the red axes. All right, so now let's give this a name. Right click properties, and let's call it a shaft assembly. I'm just gonna copy it, Control C, and paste it onto the part number, Control V. And okay, there it is. Now, the instance is if you drop more than one. So if you create multiple copies, watch what happens if I right click, copy. Let's say we're going to do multiple binders with the same name, with the same items inside. If I paste, I want you to notice that it calls it, oh, number 1. Paste again, number 2. Now, even though these are identical, you can move them around in different locations. Okay, so I just wanted to show you the instance name. It'll just keep going in numerical order, 1, 2, 3, and so on. Since we didn't put one at the first one, then it'll continue on with 1, 2, 3, and so on. Let me hit undo. So that's the instance name. Okay, so let's take a look at the shaft assembly. So the shaft assembly is made up of the shaft. Okay, so we're going to drag and drop the shaft, or we can just right click, cut. So we're going to cut it from our backpack, remove it, and insert it inside of the binder. So notice it removed it from the binder. I'm going to stick the backpack. Now we're going to paste it into the binder. And there it is. It's inside the binder now. The shaft assembly binder. Another thing is the knuckle. Now the knuckle is buried in there somewhere. So let's use the compass. Drop it on the parts. Notice how the top motor base assembly is active. Click on the items you want to move. Now we can see the knuckle. Okay, reset the compass. View, reset compass. All right, so now we're going to drag the knuckle into our binder. So here's the knuckle. You can right click, cut, and paste, or you can just drag it. So I'm going to take the knuckle, left mouse click, and we're going to remove it from the backpack and drag it into the binder. Notice the knuckle now is inside of our shaft assembly binder. All right, so now we need a copy. Notice we have one instance. We need two knuckles. So I'm going to right click, copy, and we're going to paste it. And notice this is the first instance, so the new one will be the second instance. Right click, paste. And there it is, and they're on top of each other. Okay, so we have two instances, two copies of the knuckle. So let me drop the compass. So the mistake you're going to do is, hey, I'm going to move it over, drop it on the knuckle, and then you're going to try and move just the knuckle. Like, hey, wait a minute. Why am I moving the entire binder? Because you need to first activate the binder. So let me reset compass, do it over again. Double click on the binder. Double click. Click in space to deselect. Now the binder is active. So now you can move the things inside the binder. Okay, so activate the binder to move things inside the binder. Now drop it on the knuckle. Notice it chose the first knuckle, instance 1. Now I can move the first one. I'm going to rotate it to line it up. Grab the arc. So if you grab the arc, it'll rotate. And we're going to insert it inside of this hole. All right, so let me view, reset compass. Okay, so we're going to insert the knuckles inside the shaft, and we need to line them up. All right, so I'm going to open up the binder on its own, in its own window. It's too crowded, so I'm just going to open up the binder, take the binder out of the backpack, right click, and look for window. Open a new window, and it'll open it up in its own window. There it is. So here's the binder. We took out the binder out of the backpack so we can rearrange the pages, or in this case, the knuckles and the shaft. So let's start by anchoring the main part, which is the shaft. So let's bring over our coincidence or our constraints toolbar. So we're going to anchor the shaft, the main part, and you can see now it added an anchor. Okay, now we're going to line up with the knuckles. So what we're going to do is we're going to line up either plane to plane, or let's see if we can line up the neck of the knuckle with the axis of the shaft. Let's see if it'll allow us to. So we're going to put a coincidence between the neck, and yes, it does accept the neck of the knuckle, and hover over any cylindrical or conic shape, and it'll automatically pick the axis. Okay, there it is. It lines it up. Let's do the same thing with the other side. Put a coincidence between the neck and the shaft. There it is. And let's hit update to line them up. It happens that they are already in line, but let's see. Let's hit update anyway. 3, 2, 1. Update. So this one rotated slightly. It was slightly off. That one's already in line. Okay, so now we need a distance. Okay, so we need a distance between the two knuckles. So what we need is to go to the to this one. So there's going to be a bolt and a second bolt that goes through the holes here, and the knuckles are going to ride on that bolt, which is threaded. So what we need is the distance from this hole to this one. So it's 240. Okay, so once again, the holes of the knuckles are going to line up with these holes where the long bolts go through, and it's 240. Okay, so let's go back, and we're going to add a dimension from the axis of this hole to the axis of this one. My mistake. We're going to do an offset constraint. Cancel. Oh yeah, we were doing an offset. My mistake. Offset constraint. Axis to axis. If you can't pick the axis, zoom in. Axis. Okay, and we're going to go with 240 millimeters. And okay. and update. 3, 2, 1, update. Okay, notice it did keep the 240, but now these are not centered correctly. So we need to take 240 and cut it in half to 120. So we're going to go from the center, vertical plane, to the axis of 120, which is half of 240. So let's do another offset from this vertical to the axis or the plane. Either one will work. And let's make it 120. Half of 240. And okay, and let's update in 3, 2, 1, update. And whoa, it went in the wrong direction. So there's the 120. So you can see, we need to put a minus to go in the opposite direction. So let's double click on the 120 and just put the minus in front to change the direction. And enter and update. And there it is. So there we have it. Okay, so we're done with the shaft assembly. And let's go back to the motor base assembly. Top motor base assembly. I misspelled base. Let me right click properties and change the name. Put one too many S's. Okay. Okay, so there's our assembly. And once again, we need to line it up with the holes on the shaft. Okay, so I'm going to do a coincidence between the hole of the knuckle and the hole of the shaft. Notice how it doesn't let me pick it? The reason is because the binder is active. You can only add constraints to things inside the binder. So we need to hit escape and exit the command. Hit escape. So we need to move things within the binder. So we're going to attach the binder to the base plate inside the backpack. So let's double click in the back on the backpack or the top motor base assembly. Click in space so you can see it's blue, it's active. Now we should be able to go coincidence from this hole to this hole and hit update. Before I do, I want to anchor the main part. I forgot to add an anchor to the base plate. The base plate is the main part. Let's put an anchor on the main part, the base plate. There it is. And you can see the constraints here. And update. 3, 2, 1, update. Okay, so now we have this knuckle in line with this hole. Now we need to do the other one. Let's see if we can do it. Let me move over this bracket here and reset compass. Okay, so now we're going to put a coincidence between this hole and this one. Let's see if it'll take it. Now these holes have to be perfectly, I should say equidistant here as here, or else it will not work. If the distance between these holes doesn't match the distance between these two holes, it may give us an error message. It will if it's not the same exact length or distance, I should say. So let's add a coincidence between this hole and this one. And let's hit update, see if it accepts it. And it did accept it. And once again, if the holes were not perfectly the same exact distance, you would get an error message, even if it's off by 0.0001 millimeter. All right, so now let's add a distance between this face and the face on this side. So I'm going to add a distance from this face to this face. Now I want it to go in the opposite direction, so I'm going to make it a positive instead of the default, which is negative. Let me type in 50. And OK. And update, and there it is. I'm going to reduce it to 25. 50 seems to be too much. 25. OK. And update. All right, so now let's move to the next assembly. Next assembly is the support and the bracket. Okay, so we're going to add a new binder. Okay, so let's add a binder to the backpack. A binder made up of the bracket and the support. Okay, go back to the drawing. So we're going to call it the support assembly or sub-assembly. So we're going to put these together. Support sub-assembly or assembly. Okay, so let's add a new binder in our backpack. Product, put it inside your backpack. You have to tell it where. Okay, so we're going to add a binder inside the backpack. You can also add an assembly, a pouch inside the first binder, but no, we're going to do a separate new binder in our backpack. Okay, right click properties, give it a name, and we'll call it the support assembly or sub-assembly. Okay, I'm going to control copy and paste it in the part number name. The part number name, that's the name it'll give it give your file name when you save it. All right, so now we're going to drag and drop. So right now the bracket is loosely inside of our backpack, and so is the support. So we're going to cut and paste, or we can drag and drop. I'm going to right click the support, cut, and paste it into our support assembly. There it is. It did add it to our support assembly. And now we're going to do the bracket. Right click, cut, and paste it into your new binder, the support assembly binder. So notice we have two binders now. We have two binders inside of our backpack, and the base plate is not in a binder. It's just in there by itself. Think of it as your maybe a ruler that's not inside of a binder. It's just loosely inside of your backpack, but the base plate does come with a sleeve. So a protective sleeve cover, maybe a see-through cover, but you want to protect your ruler from getting dirty. Okay, and that's the reason it has that little red axis, because it's just an individual component. And these are assemblies. Notice they don't have the red axis. Okay, so now let's go ahead and open up the support assembly in its own window. Right click and look for window, open a new window. Okay, so let's start by anchoring one of the pieces. You know what, I'll anchor, even though the bracket is longer, I'm going to go with the support because this supports the bracket. So I'm going to anchor the support, and now I'm going to attach the bracket to the support. All right, so what I'm going to do is I'm going to put a coincidence between this hole and that hole. So I'm going to put a coincidence between the hole of the bracket and this semi-cylindrical shape, right? So I can grab the axis of this semi-cylindrical shape, click, right, there it is, and update. And it'll line it up, as you can see. So it lined up the hole with the slot, or at least the axis, the right axis of the slot and not the left one. Okay, and now we're going to do a face-to-face. Okay, I don't remember if the face goes to this surface or the other one. Let's go back to the drawing. Okay, so the bracket is, okay, this surface of the bracket touches the surface, opposite surface of the support. Okay, so let's go back. Okay, so I'm going to put a face-to-face contact between this surface, the outside surface, with this surface. And update 3, 2, 1, and update, there it is. Okay, now, what happens if I was to rotate this bracket? So I'm just going to rotate it. And let's say it was misaligned. Let me reset my compass. So let's say you wanted to line up this bracket with the support and you didn't know what to do. You can add a angle constraint. Okay, so I'm going to put an angle constraint. Let's go to angle. Angle constraint between the top of the support, this flat surface, and this surface. Or you can pick the edge. Either one will work. I'll pick this surface. Right now the angle is at 20. And I want to change it to 0 degrees. And OK. So 0 degrees and update. And it'll straighten it out. So it lines up with, so that the slot also lines up with this hole. So this bracket can slide back and forth along these two holes. We're missing the hardware. We'll come back and fix that. All right, so let's go ahead and go back to our top motor base assembly. And there it is. Okay, so the next thing is to line up this hole with the shaft. Okay, make sure you have the binder, the backpack, the top motor assembly activated. Double click, it's already blue, it's already active. So now we can move the binders inside the backpack and line up this hole with this shaft. Okay, so we're gonna line up this binder with this binder. Okay, so let's take the coincidence constraint, put a coincidence between this hole and the shaft. So just pick on the cylindrical surface and update. There it is. Now let's move it over to the left. So this is actually the left support assembly. So let me actually fix the name. I'm going to right click properties, support assembly, and I'm going to go LH. That stands for left hand support. So left hand. So I'm going to call it the LH left-handed support assembly. Okay, so left-handed, because there's also going to be a right-handed. Okay, so let's move it over. All right, so let's put a distance between the knuckle and this face. So I'm going to put a distance between this surface and this surface. You can also pick a point, by the way. You can put a distance between a surface and a point, or an edge, or a line. And I'm going to go with, let's go with 25, see how that looks. 25, offset, okay. And update in 3, 2, 1, update. There it is, that looks good. All right, so we're still missing the right-hand side, and I'll save that for last. Let's start adding some hardware, the bolts and nuts. And then we'll do the right-handed side, the support assembly RH, right-handed. We'll do that at the end. Okay, so let's bring in the hardware. So now I'm going to use the insert command. So this is insert. Click the yellow arrow. Go to the top assembly. And you're going to go to your folder where you saved it. So I'm emailing you the hardware, the bolts and nuts, unless you want to model your own, and they do not have to be accurate if you decide to model your own for practice. Okay, so let's look for my hardware here. Here it is, I have my hardware. Okay, there's not that many items, so I'm going to hold on to the control key and select all of them. And I'm going to insert them into my top motor base assembly. And open. Now where are they? They're right here in the middle. They're all on top of each other. So they land at 0, 0, 0, at coordinate 0, 0, 0. Okay. Okay, so this hardware, the long bolt is part of the binder. So we're going to line up this screw. I'm mistake, this bolt is part of the backpack. Okay, so this is not part of one of the smaller assemblies. We can go back to the handout. Notice we don't have a long bolt in any of these sub-assemblies. So it's part of the main assembly, the top assembly. Okay, so let's take this bolt, put a coincidence between the bolt and the hole, and update. There it is. Okay, so now we're going to put a, by the way, it doesn't matter if we insert the bolt through this side or this side. I'm going to rotate it so this surface matches up this surface. So I'm going to put a contact constraint. So contact constraint between the bottom of the head of the bolt and this spot face. Click and update 3, 2, 1, update. And there it is. There's the bolt. Now you can either use, no, it looks like I clicked the wrong surface. That looks like it's right. Okay, so when it comes to hardware, either you can use the hardware I emailed you, or you can model your own bolts and nuts if you like. Doesn't have to be perfect, doesn't have to be accurate. Or you can also insert them from CATIA. So CATIA does have a catalog. In the past, it was used quite a bit because it comes with 3D models. It'll generate 3D models of hardware. But now you can just download them from Carlane or McMaster or model your own. Okay, so to bring in the catalog, let's see if I can find it. It's looks like a book. Actually, there it is. Having trouble looking or finding it. Okay, so there's a catalog of hardware. Okay, so you can go to this catalog, you can click it, and it'll take you to a library of bolts and nuts. You can click in here in space and zoom in. So if you want a bolt, just click on the bolt, gives you a preview. You can follow an ISO standard if you like, the international standards. You can use the US catalog, American standards. I'm going to stay with ISO standards, the international standards, since they mostly use millimeters and not inches, right? You can double click on bolts. And let's see, you can zoom in. And it'll give you a library of different types of bolts. Okay, you can go to the pull down here. Oh, my mistake. Double click. There it is. It wasn't loading in. So I had to double click again and it loads all these types of bolts and nuts, right? So here are the sizes, right? And lengths. So this is an M14. I believe the one we're using is a M14 or M12. Okay, so here's a library of bolts and nuts you can use. And if you don't find the right length, just download one of them. So if I was to select, let's say I select this one, double click, and it'll load it. As you can see, I double clicked and it loads it in. So this is what it just brought in. Okay. And you can just double click the one that you want. If you want to bring in a nut, for example, let me go to the tree here. Let's see, let me exit so I can pick hex nut. Go to catalog again. And I'm trying to go back to hex nut. Let's see if I can go to the drop down here. Go back to ISO standards. So I went back to ISO standards, and if I bring in want to bring in a hex nut, there it is, the folder of hex nuts. Double click. Okay, so what style do you want? Do you want a hex nut with the washer or just a plain hex nut? I'll just randomly pick one. Double click. Let me double click again. There it is. It loads it. So I was looking for an M12 or M14. Let me just randomly pick one. I'll use an M12. I don't see an M14. Okay, so double click and it'll load it. And there it is. It brings in an ISO standard nut. And okay. And let me go ahead and close my catalog. Okay, so you need to do this inside of an assembly or else it will not load it. If you're in part design, it will not load it. You have to be in an assembly to load hardware from the catalog. Okay, so if it's not the right length bolt that you're looking for, then just alter the bolt, make it longer, and save it with the new name. Okay, so I'm just going to go ahead and delete these. I just wanted to show you how to bring in. So I'm deleting it, and it creates a window. When you delete an item that has not been saved, it'll take you to its own window. Let me go back to the motor-based assembly. Let's delete this ISO hex nut. I'm going to delete it. Hey, do you want to open it in its own window because you haven't saved it? Nope, it's okay. I don't want to deal with that. Okay, so here we go. All right, so, or once again, you can just use the one that I emailed you. All right, so now let's line up the hex nut with this bolt. Okay, let me use the compass to spread things out a little bit. So let me use the compass and just drop it on there. Let me just pick this first, this smaller screw. Just move it out of the way. Grab this hex nut. I'll pull it upward. Here's a smaller hex nut. Notice how I saved the bright colors for the smaller items. And we have the set screw. Okay, so let me reset compass, view, reset compass. All right, so let's go ahead and add this large hex nut to the screw. So let's use coincidence and zoom in far enough so you can grab the axis. There it is, and the axis of the bolt. And let's go contact face to face from this surface to this one. Ooh, maybe I need a washer for this so it doesn't damage the surface. I'll leave out the washer and let's hit update. And there it is. Okay, so I'm going to make a copy and place them on the other side. Okay, so I'm going to use this long bolt and this hex nut. And these are M12s. So those are diameter 12 holes and shaft. And copy. And right click at the top, backpack, and paste. Okay, there they are. Okay, using the compass, just drop the compass on a flat surface or plane. Select the bolt. Hold on to the control key and the nut. So this is the new bolt and nut. And now I'm going to slide them over with the tree. Let's reset our compass. Okay, so now let's add some coincidence between the bolt and the hole. And face contact between the spot face and the bolt. And let's go ahead and hit update. Okay, now let's do the nut. Coincidence between the hole and the bolt. I'm going to speed it up a little bit. Contact face between the tab and the hex nut and update. All right, so we took care of that. Okay, now we need a set screw. So this is a smooth shaft. And as you can see, the support slides along the shaft, but it'll rotate and since it's on there and it's a nice inline fit, it's still loose. We need to screw it down or lock it down with a set screw. So here we have a set screw. Okay, so we're going to put a coincidence between the set screw. As long as you pick a cylindrical or conic shape, it'll pick the axis, and let's pick the axis of this hole, this tapped hole. And now we're going to do a offset between this surface and this surface. And I'll leave it at 0 and I'll adjust if need to. Hit OK, and we're going to update. And there it is. Okay, so to prevent this support from sliding or from rotating along the axis of the shaft, we tighten the screw to lock it in place. We don't use a regular screw with the head because we don't want to over tighten it and damage the shaft. So we use little set screws where it limits our torque and we don't over tighten. Okay, so let's go ahead and add the screws into the support and the bracket. Okay, so this bolt and this screw goes with the bracket and the support. So we're going to have to drag them into the support assembly binder. Okay, so this is the binder. We want to drag this small bolt and nut. Okay, so I'll just drag it and watch how it populates the binder. Okay, so here's the bolt. We're going to drag it into this binder. There it is. And now we're going to take the hex nut and drag it into this binder. There it is. So the binder, as you can see, anything in orange is part of this binder. And just to verify, notice how we have the bolt and nut part of this left-hand support assembly. Okay, so We can add the constraints here between this bolt and nut onto the support, but we need to double click on our binder here, our support assembly left-hand side. We need to double click to add constraints between these items. Okay, so let's go ahead and do that. Okay, so let's add a coincidence between this bolt and this hole. And let's do a contact between this face and this face. And let's hit update, 3, 2, 1, update, and there it is, there's the bolt. Okay, now let's do the hex nut. Okay, so let's do a coincidence between the hole and the screw. And finally a contact between this surface. Oh, wrong surface, hit escape. We're gonna do a contact surface. We should actually put a washer. I left out the washers by mistake. We'll just leave them out just for time. Surface and surface of the nut. Okay, and hit update. And 3, 2, 1, update. Yeah, so we should have added a washer. I'll just leave it out just because of time. All right, so now we need a second set of screw and nut. So I'm going to make copies of the screw and nut. Hold on to the control key, select them, copy, and paste it back into the binder. Notice now these are coincidence 0.2. So the first two was coincident 1 and 1. Now we have coincident 2 for the screw and coincident 2 for the nut. They're copies of each other, so if one screw is altered, the other one will also be altered. Okay, so I'm going to use the compass. I'm going to drop it on this surface. Then I'm going to pick the nut, the second nut, not the first one, and I'm going to just slide it along this surface, pick the inside surface here. There it is. And I'll pick the second screw, not the first one, but the first. First one's already constrained. And slide it over or upward. Okay, and let's reset the compass. Again, note that this binder is active. It's blue because we're moving items inside of this binder or constraining inside this binder. Okay, so let's go ahead and add some constraints. So we're going to put a coincidence between the bolt and the hole. And a constraint between the nut and the bolt. And let's add contact constraint, contact between this surface and this surface. And let's put a contact constraint between this surface and this surface. Okay, and we're going to update in 3, 2, 1, update. And there it is, everything looks good. All right, so looks like we're almost there. Let's go ahead and close this binder. Okay, so let's go back to our main assembly. So all we're missing is the right-handed support subassembly. Okay, so we have everything. The only thing missing is this right-hand support assembly or subassembly. Okay, so here's what we're going to do. Let's go back. Instead of having to model these, what we can do is we can do a mirror at the assembly level. Okay, so we're going to do a mirror at the assembly level. So let's go to the top assembly, double click on the binder, and we're going to do a mirror. Let's see if we have it in here, the mirror command. If not, I can always go to the drop down menu, looking for mirror, and I don't see it. Okay, let me go to the drop down. Okay, here it is. I don't see mirror. Oh, but I see symmetry. That'll work. So we're going to do a symmetry of the left hand. Okay, so go to the drop down insert. We're going to do a symmetry. Click on symmetry. Okay, select the symmetry plane. So we're going to mirror about the center here. So we're going to mirror this over to the right, and we need to pick a plane that's right in the middle, and we're going to select a vertical plane. It can be this one or this one. So we're going to mirror about this plane, mirror the left hand side bracket assembly over to the right. So as long as you pick any plane that's centered, this is the center plane of the base assembly. So I'm going to select it. Okay, now it's telling me what do you want to mirror? Okay, so we're going to mirror this entire binder here, the support, the left hand support assembly. Click. Notice it's giving us a preview. So there it is. It's mirroring everything over in that assembly. All right, so you can mirror everything. You can mirror the geometric sets, the sketches, the pads, the pocket command. You don't need to mirror everything, but you have the options to mirror multiple items inside of each individual part. We don't need to do that. So we're just going to keep it at default. Okay, and once we do finish, it'll generate and create new files for the right hand side. Notice this is the name it's given them. Now, one thing we do want to keep is a link between the positions, so it's always mirrored about the position of this one. And we do want to keep a link between the two. So if one changes, the other one will also change. So we do want to keep the links, keep these on. Okay, you also have the option to rotate, translate. We're going to mirror it, leave this alone. We're just going to mirror. Okay, so you do have a bunch of options here that you can pick from. I'm going to leave it alone with the default settings and hit finish. Give it a few seconds and there it is. It generates new files. Okay, so now the right way of doing this is to rename all of these. Remove the symmetry and put RH. So this would be the support assembly RH. And we can call this support RH for right hand, bracket RH. And the screws and nuts, we can leave them alone. But typically, out in the real world, you don't want to use the name symmetry. Okay, so, but I'll just leave it just for time. I don't want to go in and change everything. Okay, so here's the cool thing about symmetry is if you alter the original part, let's say I add a big hole on this part. So if I want to go to part design, all I have to do is double click. So if I want to make a change on this part, instead of having to open it in its own window, I can just double click on this part. And look, it'll send me to, geometric set. My mistake, surfacing was the last workbench I used for an individual part. So I double clicked. Notice that this is blue. See how the bracket is blue? So this is what's active. Now currently I'm in the surfacing workbench. Let me move over to the part design workbench. 3, 2, 1, part design. You'll see it'll take me to the part design workbench and the bracket is still blue, letting me know it's active. So I'm going to add a big hole here. Why? Just for fun, just to show you what happens. Okay, so I'm going to add a large hole. I'm just going to exaggerate, make it 25 and enter. Notice how this one turned red. This bracket is linked to the left-hand bracket. So the right-hand bracket is linked. So if there's any changes to the original one, and because we maintained the link when we did this mirror command or symmetry command, this will also update. Okay, so now let's go back to the top assembly. Double click at the top assembly. So it'll be able to update. Here's the update command. And in 3, 2, 1, update. And watch what happens. It updates. That's the cool thing about the symmetry command. These two are linked because we chose to keep the link between the two. Okay, let me go back. Go back to the bracket, the left-hand bracket. It takes me back to part design workbench, and I'm going to remove that hole. Delete it. Okay, and it turns red. The right hand turns red, knowing there's been a change to its twin or its opposite, its evil twin. And let's go back to top assembly so we can do an update. Notice it's blue now, and update. Okay, and the only thing missing is we need a set screw here. So I need another set screw. Okay, so I'm going to make a copy of the set screw. Copy. Paste it into the top assembly. Notice it's coincidence number 2. Okay, so I'm going to use the compass to drag it over. Reset the compass, view, reset compass. And let's put a constraint of coincidence between the hole and the set screw. And let's use an offset between the face of the set screw and the surface. Okay, let's keep it at 0. Okay, and update. And there it is. So let me redock these toolbars. All right, so now we're ready to save. If you have not saved this, but one thing I wanted to mention is when I check your work, I'm gonna do an exploded view. Okay, but before I do that, let me go ahead and save this. So I'm gonna go to File, Save Management. These are all new items except for the hardware. So the ones that show open, those are that's the hardware that I emailed you. The ones that are new, these are new files that we created, the support, the brackets, the knuckles, the shaft, and the base plate. Okay, so let's go to the top assembly. Okay, so go to the top motor assembly. There it is. It gives you a preview. So top motor base assembly. So once you save the top assembly, it'll auto save everything else. Okay, so I'm going to go save as. If you want to save it on your flash drive, I'm going to go ahead and save it on I'll go ahead and save it on my flash drive. Okay, and I'm going to create a new folder. And I'll call it a base, or I should say a motor base assembly. Click away to create that folder. Double click now to open the folder. And you're going to save your top motor base assembly in this folder, this new folder. And save. And notice it's auto saving all the files. Now this one is not auto saving. Remember, this is from the catalog. We chose not to use this one. This is the one we downloaded from the catalog, the ISO standard bolt. It's open in its own window, but we're not going to save it. We chose to use our own bolt. If we would have used this bolt, then it would have also auto saved it. Okay. Okay, now let's go to back to our top motor base assembly. It has not saved anything. Notice how it says auto save. Any item inside of our top assembly, it'll auto save. But now we want to move everything into this new motor base assembly in our flash drive or your desktop. So I need to hit propagate so it saves it all in the same folder. Keep it all together. You want to keep everything in one folder. So once I hit propagate, watch what happens to its locations. Propagate, notice. It's going to move everything that's part of this top motor base assembly and all its hardware and components and save it on that folder. Okay. So I'm going to go ahead and hit OK to save. You have to hit OK or else it will not save. Whoa, these files are way too big for my flash drive. I'm going to hit OK. Okay, so it happens that my flash drive is already full. Okay, so let's say we saved it. So let's say it's saved. I'm gonna go to my flash drive. Okay, so yeah, I did not create that folder. This flash drive was just too much, so. All right, so once you save that folder, once you save your components, right click on that folder and create a compress folder so you can email to me. Okay, so it failed on my end, but just to save time, let me continue. All right, so when you send me that zip folder, it's going to send me a file of all your components. Don't make the mistake of just sending me your top motor base assembly file, your CAD part file, or I should say product file. It has to include all the hardware and parts. Okay, so let's say I open your file. So you emailed it to me, the zip folder with all your files that make up this assembly. So what I'm going to do is I'm going to use the explode command to check to see if everything's constrained. Okay, so I'm going to use explode. going to hit explode. It's giving me a warning when I hit OK. Are you sure you want to explode? So you can see everything is being exploded all over the place. And yes, things go flying all over the place. And now I'm going to hit update. So if I constrain this correctly, it should all go back to its constrained position. 3, 2, 1, update. And it all goes back. Oh, except the set screw. So this set screw, I missed it. So somehow I missed constraints on this set screw. Update. Oh, there it is. I hit update again. Somehow it missed it. But I hit update again. And it recognized the constraints and it placed it back. I think it's because of the symmetry parts were not constrained. The symmetry parts are constrained with respect to the left-hand side. So I think it first had to constrain the right-hand side before the set screw can recognize its constraints to this symmetried parts. All right, so end of motor base assembly.